Hello friends, I welcome you all to this session on graph theory. So what I'll be doing today is, as in the coming lectures we have to prove the theorems. So before that, I think it is the correct time and place to tell you about sets, or basically to just revise about sets and also about the parity. So the sets which we will be talking about is number set. So what is a set basically? Set is a collection of things or objects. So if I'm having, let's say, a letter B, number one, and let's say I'm having this dollar and anything, let's say a Dale. So these all are what? They are collection of letters, symbols, and numbers, isn't it? So this is what we call as a set. So let's say this set is S, then in the proper representation form, I can write this as set in the curly braces, and these are what they are, the elements of the set S. So if tell that, if I ask what is one, where is one, so you can say that one is uh, basically an element of this set S. Okay. Whereas if somebody say that whether let's say Dale is element of S, no, it is not present in S, so it is not an element of S. So in the same way, we are having sets of numbers. So those are called as number sets. So in number sets, there are so many different types. So we will be starting with the basic one, which is called as the natural number set. So the first one is natural number set. It is represented as capital N. So what are natural numbers? They are the whole numbers, complete numbers, starting from 1 and moving up to infinity. So if I write this set, then this will be 1, 2, 3, and so on. So this is what the natural number set is. Then if I ask you what is integer, they are basically represented as z. So what are basically integers? The whole numbers which are ranging from minus infinity to plus infinity, they are integers. So z is nothing but all the numbers from minus infinity to plus infinity. So in between, so let me write it, that it will be having minus 1, 0, 1, 2, and so on. So many numbers, but all the numbers should be whole numbers. So if you look these two sets, then you can very well appreciate the fact that n, that is the natural number set, is inside the integer set. Now there's another set known as real number set, or let us talk about rational number first. So rational numbers they are represented as q. So what are those? So the numbers which can be represented as p by q, where q should not be 0. So they are what? They are rational numbers. So all the numbers, let's say 4 by 2, 3 by 5, 9 by 8, they all are rational numbers because they are represented as this, and the denominator is not 0. So if you watch this closely, then you will be able to see such types of numbers as well. And they are nothing but they are whole numbers. They are coming out to be whole number if you solve them. So therefore, we can say that the integers are inside the rational numbers. Okay. Now, once rational number is clear, there are numbers which you cannot represent as P by Q form. So those numbers are called as irrational numbers. They are represented as Q bar. So what are they? So the numbers which I cannot represent as this, what are those? Let's say pi and square root of 2 and e, etc. They cannot be represented as P by Q form. So they are what? They are irrational numbers. Then comes real numbers. Real numbers are represented by R, and they are nothing but the collection of all the rational as well as irrational numbers. So the collection of both is what we call as real numbers. So they will all the numbers which are falling on real number line. Then comes your imaginary numbers represented as I. What are these? So imaginary numbers are basically the one. So you might have observed this -1. What is this? This is iota, and that is what an imaginary number is. So if you look, these numbers don't have any place in the real number line. So let's say it is -√9. So it is what? It is 3i. I is called as iota. So they are entirely different from the real numbers. Then comes this complex numbers. So you know that complex numbers are normally represented as a plus bi. Okay. Now, if you look this closely, then this is what? This is a real number, and this is what? This is imaginary number. So if you add up these two, real and imaginary set, then you will be landing up to a set which is bigger one, and that is the complex set. So therefore, if you want to represent these sets in pictorial form, then what you can say that this is your natural number set. Then this is inside the integers. Okay. Then what? Then all the integers will be the part of rational numbers R. And then there will be a set which is entirely different from rational numbers, and we call it irrational numbers. Sorry, rational numbers are represented by Q. So irrational numbers, that is Q bar. So the rational number, irrational number. And if we collect these two, then we will be getting what we call as the real number set. And the numbers which are not on real number line, they are what? They are nothing but imaginary numbers, I. And if we club the real and imaginary both, then we will be getting a bigger set that is called as complex. So the complex number can be thought of as the outermost or the main set of which these all are the subsets. So you should remember this. This is a very important thing to understand any of the mathematical concepts. Now comes the another part, which is what we call as parity. So what is parity? The parity is whether an integer is even or odd. So if an integer is even, then it has to follow 2k rule, where k is nothing but integer. And if the number is odd, then that should be following 2k plus 1 rule. Again, this k is integer. For example, if let's say I want to show or check whether number 8 is integer even number or not, then the simple thing which I must be asking to myself is whether I can write this k as 8 as 2 times some integer, and I know that is nothing but 4. So therefore this 8 is following 2k rule, and hence it is integer, sorry, even number. Consider, let's say, minus 10. So whether it is even or odd, then I have to again check whether it follows this 2k rule or not. So what integer should I multiply by 2 so that it becomes minus 10? So it is minus 5. So again this is following 2k rule, and hence it is even. Whereas if you look, let's say, 9, then can I write this 9 as 2k? Let us check. What number should I multiply by 2 to make 9? There is no number, no integer which I can multiply by 2 and that will become 9. So, is there any integer which I multiply by 2 and then add 1 to it so it becomes 9? Yes, I can do it. So, if I multiply it by 4, then it becomes 8, and when added to 1 it becomes 9. So 4 is integer, so therefore it follows 2k plus 1 rule, and hence this 9 is odd number. So in this way you can check even and odd. Not only this, if you want to prove some of the basic things like whether let us prove it. Let's say whether I am interested in proving that or checking that whether odd number plus odd number is even or odd. So let's say the first odd number, how we write odd numbers, they are written as 2k plus 1. Now this is also odd, so this will be 2k plus 1. So what is this? This is 4k plus 2. Okay, so I can take this 2 common. So this is nothing but 2k plus 1. Now, what is this k? Integer. When multiplied by 2 will be again integer, and when added to 1 it will be an integer. So this whole is an integer. Let's say it is k prime. So this is 2k prime. Oh, so odd plus odd is following 2k prime, that is 2k rule. So hence it is even. Likewise, uh, whether even plus even is odd or even, let us check. So even they follows 2k rule, and this is again 2k. So it is 2 times 2k. Now 2 is integer, k is integer. So integer times integer will be an integer. So this is, let's say, k prime. So this is, so again this is following what? 2k rule. So therefore even plus even is even. And there are so many things you can do with it. You can prove many things like odd times odd will be odd, even times odd will be even, and even times even will be even, and even minus even is even, odd minus odd is again even. So there are so many things you can prove. Okay, so in this lecture what I have discussed with you is that about sets first, and second about the parity. So they both will be of great help in proving the theorems which we will be learning in the next lecture, which are related to the graph theory. So in this lecture, till this point only, in the next lecture we will be continuing with the theorems. Thank you very much for watching it.